Okay, question 11. If a shark is spotted, a lifeguard will activate the siren. Okay, nice to see what's going on. If you see a shark, there's going to be a siren. Great. The sound intensity I of the siren varies inversely with the square of the distance d from the siren, where d is greater than 0. Okay, so this looks complicated. There's a picture of a shark, etc., etc. But when I read that, I see this is an inverse proportion question, and I know how to do that question, so I want you to think the same way. It is known that at a distance 1.5 meters from the siren, the sound intensity is 4 meters per square meter. So perfect. That's the kind of initial values that they always give us in order for us to solve this. So the sound intensity I, so let me write this one here, I varies inversely with the square. So I can, if it varies inversely, I can say I is equal to k, some constant, over, because inversely means over, divided by, so k over the square of the distance, which is d squared. So that's the first line you got to write down. Then it says when d is 1.5, so when d equals 1.5, I is equal to 4. So we can sub this in. I can say 4 equals k over d squared, which is 1.5 squared. And then k is equal to 4 times 1.5 squared. So if you multiply that by this, 1.5 squared is actually 2.25, and 2.25 times 4 is 9. So k is equal to 9. You can solve that using NSolve if you don't like what I did in the calculator, but I don't think that's too hard. Just 4 times 1.5 squared in your calculator and you get k equals 9. Therefore, I is equal to k over d squared, which is 9 over d squared. And that is what they wanted us to show that this is this. I like to write QED, which means shown. Okay, sketch the curve of I on the axis below, showing clearly the point 1.54, right? So let's just sketch it with the calculator. Okay, let's delete this. Yes, let's change the zoom back to normal, guys. And let's sketch this. So we're going to do D is the X axis, and I is the Y axis. So I'm going to do 9 over X squared. Remember, when you're graphing, you have to use X. And we get this. So it's from 6. So let's actually change our windows, guys. Window settings. Because he wants me to do it from 6 to 20. So I'm going to go, the X min is 0, the X max is 6, and then Y min is 0, and the Y max is 20. So it looks something like this. Okay, I'm just going to go like this, something like that, fine. It doesn't have to be perfect, but so long as it's, I always struggle drawing graphs with this. Okay, as long as it looks something like this. Is that good enough? No, I don't think it is. Let me try that one more time. And by the way, it says clearly showing the point 1.54. So let's actually get that point here to show where it is. Trace. Now if I type 1.5 here, there's the point 1.54. So I'm going to have it down here. Okay. Okay, I'll try one more time. Alright guys, you get the point. My graph, that is not great, but that's all I can do. So I'm going to do here, somewhere there, 1.54. 1.5, comma 4, because it says show clearly this point. So this is the point when the distance is 1.5 meters and the sound intensity is 4 watts per meter squared. Okay. Part C. Whilst swimming, Scarlett can hear the siren only if the sound intensity at her location is greater than 1.5 times 10 to the minus 6. So that's a tiny number. Find the values of D where Scarlett cannot hear the siren. Right, now normally, guys, I would say go to your graph and then find where this is below. Okay, let me go back here. So the number is 1.5 times 10 to the power minus 6. So this is basically when he's at, if you look at the values here, this means when he's at 5 points, or when she's at 5.7 meters away from the siren, this is the sound intensity. When she's at 6, this is the sound intensity. So we need to keep going until the sound intensity gets to this value, 1.5 times 10 to the power minus 6. But that's going to be a long way away. Now, normally what I would say is let's solve it using, let's draw this graph. We'll draw the graph of 1.5 times 10 to the power of negative 6, like this, and it's some straight line here. Now, unfortunately, it's so small and everything's happening so close to here, I can't actually see what's going on. So I'll try the zoom fit. This is not good at all. And then you zoom out. Okay, I still have a problem where it's just going to be very hard for me to see where it actually hits it. So instead of using this method, which is actually normally my preferred method, I'm actually going to use, numerical solve. And I know numerical solve is fine because there's only one solution to this. It's only going to cross this once and then it's going to stay below it. So numerical solve is here, numerical solve, and I'm going to type in the equation. So the equation is not where does 9 over d squared, and I can actually use d in this case. So it's 9 over d squared where does 9 over d squared equal 1.5 times 10 to the power of minus 6. And remember, you have to do comma d, and this is the answer. Okay, now so I'm going to write down the equation. So 9 over d squared equals 1.5 times 10 to the minus 6. And then the solution is d equals 2449.49. 2449.49. But remember, guys, you would lose at least 1 mark for this. It says find the values of D where Scarlett cannot hear the siren. So this is where they're equal. She can hear this, and she can hear it. Anything less than this, she could hear it fine. If it was 2,400, she could hear it. 2,449, she could hear it. She couldn't hear it if it was 2,450. Anything bigger than this, if the distance is greater than this, she won't be able to hear it. So you have to write down D is greater than 2449.49 if you want to round it to 3 significant figures, fine, but I prefer to just put that in. You'll definitely get all the marks for that. Okay, that is question 11.